Hi, this is Alex from devstories.eu. NVIDIA NeMo Guardrails, Episode 3 of 10. Relying on a massive 70 billion parameter model to do basic content moderation is a massive waste of compute. It is slow, expensive, and takes processing power away from generating actual answers. The fix is specialized content safety with Nemotron NIM. Instead of asking your primary application model to both write code and check for toxicity, you've split the workload. The main model handles the complex reasoning and generation. A second, much smaller model handles the security. Specifically, we are looking at the Llama 3.1 Nemotron Safety Guard 8B v3. This is an 8 billion parameter model fine-tuned entirely for one job, which is evaluating content safety. It runs as a standalone microservice, or NIM, which NeMo Guardrails calls out to over an API. To set this up, you define a Nemotron NIM in your Guardrails configuration as a distinct model. You label its type as content safety while your primary model remains the main type. This distinction is critical because Guardrails routes traffic differently based on these labels. Once configured, you activate the safety guard as an input rail and an output rail. When a user sends a prompt, Guardrails intercepts it before it ever reaches your main model. It sends the prompt to the Nemotron Safety NIM. The NIM evaluates the text against 23 specific unsafe content categories. These categories cover everything from hate speech and violence to sexual content and criminal planning. Consider a multilingual application where a user submits a prompt in French asking for step-by-step instructions on how to hotwire a car. The input rail catches this. Guardrails shicks the French text to the Nemotron NIM. Because the safety model is trained on multilingual safety data, it understands the intent regardless of the language. It flags the request as falling under the criminal advice category and returns an unsafe signal back to Guardrails. Guardrails then immediately halts the process and returns a standard refusal message to the user. Your main model never even sees the prompt, saving you the inference cost of processing a toxic request. The exact same logic applies in reverse for output rails. If a seemingly harmless prompt somehow tricks the main model into generating an unsafe response, Guardrails intercepts that generated text before it reaches the user. It sends the output to the safety NIM, checks it against those same 23 categories, and blocks it if it violates the rules. Setting this up requires updating your configuration files. You declare the Nemotron model in your models list, pointing it to your NIM endpoint. Then you enable the default self-check input and self-check output flows, explicitly telling Guardrails to use your content safety model for these checks. You do not need to write custom prompts instructing the model on how to evaluate toxicity. The Nemotron model expects a very specific prompt format to evaluate text, and NeMo Guardrails formats that API call automatically under the hood. You just point the rails at the NIM and let it do the classification. Decoupling your moderation logic into a dedicated, smaller model ensures your primary application model spends its cycles generating value, while a specialized guard efficiently handles the perimeter security. That is all for this one. Thanks for listening and keep building.